Hey, hi everyone. My name is Ibe Omodolo. I am one of the co-founders of Lensa Technology. Lensa Technology is a parent company, and then our first product is LensaSim. So today, what I want to do is to show you how to use LensaSim. We'll be actually trying to do a very simple process, and that simple process would get us up speed on how to use the LensaSim. Again, this is going to be very simple, very simple. I would expect that even if you don't understand chemical engineering or process engineering, you would be able to follow along. This is one of the number of videos we're going to be making. But again, this is just introductory, very simple, very basic, but expect subsequent videos to be more complex, but I'll try my best to make it as easy as possible so that you guys can all go along with me on this journey. Now let's get back. What do we want to do? We want to separate a benzene toluene mixture. Simple. And this mixture has 50-50 benzene and toluene. In order for us to be able to separate this, we need to put the component, put the feed, and like that. But we're going to be using our software. Our software is so easy to use. Our software is LensaSim, so easy to use, amazing interface. You'll see now. So let's get started. So then we don't waste time talking too much. But I really want you guys to see this. It's gonna blow your mind. Okay, so I would start by sharing my screen. The first thing I would like to share here is the problem statement, or maybe I won't say problem statement. What I've been able to do is to try to put all we need together in a very simple way. So I want to separate this mixture of benzene and toluene. I hope you can still see my screen. And what I want to do here is I made it so easy that you can see the schematic, right? You see the benzene, benzene toluene feed, I beg your pardon. For us to be able to separate that, we need to heat it up first. So we need a heater. And the next thing we need is the distillation column itself that does distillation, the distillation process, the separation process itself. And then we're going to have a distillate, and then we're going to have a bottom. Okay. All right. I have the conditions that we need here to make it easy for us. We have a feed that has a total flow rate of 100 kilomoles per hour. I beg your pardon. And then an inlet temperature condition of 25 degrees C. This is the pressure, and this is the mole fractions. Okay. I've made it so easy. Now let's get to the software itself. Let's get to LensaSim. I will share my screen now so you see LensaSim. Okay, so let's see LensaSim now. Boom. So you can see LensaSim. Amazing. You can see this is very amazing, modern, and I'll walk you through on how you can get started with using our software. Okay, so let's get started. When you log into www.lensasim.com, LensaSim is one of our products, right? It's our first product. Our parent company is called Lensa Technology, but don't let me go into that. But our focus here today is to use our product LensaSim to carry out a separation process, distillation process. So when you log into lensasim.com, it brings you here, and what you need to do is where you see our interface. This is, if I click learn now, it's going to show me a lot of modules I need to learn. If you want to get certification, you go here, learn, we get some certifications that will help you. In subsequent videos, I'm going to be explaining all this, but because the focus today is just to show you how to use LensaSim to carry out simulation. So one of the things you need to do first is to sign in. Now you're going to need to sign in with your email address. So you see me, ebay@lensatech.com. Each time you sign in, it generates a unique code to the email address you provided. So now I go and fetch that code that was sent to my email. Good. I hope you're still following me. And then I go back now and log in. Boom. Okay, you see now that it has my name that I've signed in as eBay. So if I want to start the simulation process, I need to hit open simulator. It's going to open on a new tab. So go to the new tab that has been opened. Then you can use that to do the simulation. So I'll show you now. Okay, I hope you see now. Okay, good. So you see the first thing that comes out is that it wants you to specify the components and then the property method. So remember, we're doing benzene toluene mixture. So that means the two components that I need is benzene, which is the first one here. You can search it here. And the next thing I need is toluene. So after you specify, it tells you, it suggests to you the property method. So because of the case of this, because of this study, I agree with what our software is suggesting here, that we need to use the ideal, which is the route law. So you see, so I click the ideal law and I go to continue to simulation. Good. So when you click continue simulation, it brings you here. So if you look at the interface now, you see that I have a guide here. There's a guide on. You can turn it off at any time. So, but for beginners who is still trying to explore our software, you can put on the guide. I will leave it on so that's for beginners. So it kind of guides you along the way. So it tells me that the first thing I need to put in is the feed. Yeah, I need to put in the feed. Now it tells me that I need to add the equipment. Remember what I said. We have a mixture of benzene and toluene, and that benzene and toluene is at room temperature. So, and then I need to heat it up to vaporize it. So I put a heater next. Then you need to connect the heater and the feed. Okay. Now, I hope I'm not too fast, but I really want you to get this, guys. Everybody connected to me now. You need to understand this. So now you see that I have the feed, I have the heater. Now, when the feed gets to the heater, it gets vaporized, right? And then it gets to another equipment where the actual separation takes place, which is the distillation column itself. So I need to now connect the distillation column and the heater. So my vaporized feed gets to the distillation column. Distillation process takes place here. And I'm going to have two products. My first product here, which comes out here, is the distillates. And then I'm going to have another product here. The other product is the bottom. Good. The feed comes in at a specified condition. It gets heated up. Then the vapor goes to the distillation column where distillation takes place. And then after distillation takes place, I have my first product, which is the distillates, which is the one that has the lower boiling points. And then I have the product here, which is the other product I beg your pardon, which is my bottom. Okay. Now I need to specify the feed. Now the feed comes in at room temperature of about 30 degrees. Then the pressure is 101.325 kilopascal here. I have a total feed of 100 kilomoles per hour. Now remember I said it's a 50-50 benzene toluene. So the mole fractions will be 0.5 here, and this will be 0.5 here. So your first check is that everything must sum up to 1. Good. So now I've been able to specify my feed conditions. And then the feed flows to my heater here. The heater heats it up. I'm going to put a temperature of about 92. You want to put a temperature that is able to vaporize your feed. So maybe, okay, let's do 90. But just make sure that it's a temperature that is enough to vaporize your feed. If you put a temperature like 40, it's not up to the boiling point of benzene and toluene. So what determines this temperature is what is the boiling point of your feed, because you want to vaporize it, okay? Now we go to distillation column. Now I need to specify what's my light key, what's my heavy key. Now benzene has a lower boiling point than toluene. So the benzene is the light key here. I put that here. Toluene is the other component here, which is the heavy key. And what I want is that I want almost all my benzene to go to the distillate. So here I can put 0.99 here. And here I also put 0.99 here. Okay, so the condenser pressure 101.325 here, the boiler pressure to 101.325. Okay, so you see that my guide tells me that, oh, I am done specifying every equipment. Let me make it bigger for those of you so you can see it very well. Apologies here. Good, 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 good. Well, you can, again, you can play with it as you like. It's so, I love it. I love it. I love it. Good. Okay. Yeah. Okay. Now, the next thing after everything has been specified, you need to run it. Boom. It converges in 10 milliseconds. How am I sure that this is accurate? Maybe somebody is asking me and saying, oh, are you sure this is accurate? There are many ways. The first thing you probably want to use, or which I suggest you use, is to do what we call mass balance, right? For those of you who are not chemical engineers, it's just as literally as it sounds, mass balance or mole balance, meaning that the total feed I put in must be equal to the total feed that goes out. So let's come here now. If you see remember my feed is S1, right? And I have two products, S3 and S4. So I put in a feed of, let's use the mole fraction to judge. Good. Put in a feed of 100, right? But then you see the product S3, which is my benzene, is 50, 50. So it balances, right? So the total feed in must equal the total feed out. So that's the simplest way for you to judge to see if what you put in is actually what is coming out. Okay, good. So it tells you other things, right? It tells you the entropy flow, the other things that might be of interest to you. And yeah, what I've been able to do today is I've been able to show you how to use LensaSim to separate a mixture of benzene and toluene. You can see how easy it is to use. And then you have the guide on. And if you have Pro Access, you have the AI assistant you can use anytime you are stuck to guide you. But again, we already have a guide tool, but if the AI assistant is going to help you to explain the data if you're confused, how do you report the data? You know, some of you are students that you're joining me, and then you're saying, how do we send this to the professor and all that? But then, like I said, software and video are going to explore our website a lot, right? So you're going to see that even as a professor, how you can set up a class and how your student can just join and then you are training them. So if I want to show this data that I have now, I want to report it. If you come here, you see it tells you export in project file. Here it tells you generate a design report, but you need a pro access to be able to do that. So like if I click this, it's going to open on a new tab. So I'll show you how that looks. You're going to love it. It's amazing, amazing, amazing. So let's show you that. Actually, I'll show you that. Good. So you do see the design report now. Beautiful. So the design report comes out as a PDF, which you can just take and you see it shows you the PFD, the flow sheets. You can see I'm using PFD. Maybe if you prefer just use flow sheet, that might be easier for you. So it shows you all the conditions, the interpretation, the heater, the cooler, the product that we get, the cool, beg your pardon, the stream tables, convergence, this is amazing. So this converts in 10 milliseconds. Compare this with what you have, if you've done process simulation before, compare this with what you've ever used. I'm not here to demarket other people's product, but just think about what you've used before. If you've graduated as chemical engineering student or you've ever tried to learn simulation, compare this with what you've ever used. Process simulation is the closest that you will get to the reality of what you are learning in chemical engineering. Look at process simulation as somebody trying to build a house. And then you need to draw the architectural diagrams, right? It's actually a diagram that gives you insight to how the house will look like. And from there, you can now go and build it. That's what process simulation does. It tells you how the plant you're trying to design is going to look like before you actually build the plant. One more thing I need to show us today before I let us go. Again, this is going to be just a short video for today. Let's go back to the simulation. I'll show you something in the simulation now. Let's go back to the simulation. There's something I didn't show you, which I will quickly show you before we end today's class. Good. So you can see my simulation environment again, right? Good. Now we have been able to design our software that each time you build a plant, you simulate it, it does the techno-economic analysis instantly. They are all embedded. So you see the techno-economic analysis of these plants. If I was going to build this plant, you see the results here. Beautiful, amazing. I hope you've been able to learn something today and you're able to see the beauty of our software. We're going to be having these videos like this, subsequent videos to show you. I'm starting very, very basic. Next video too might be also be a bit basic too. Maybe we find something also very simple for you to understand. Basic before we start building complex plants itself, simulating complex plants. But I want to just start from something simple for everyone to follow. I hope you are really excited as I am here. I could imagine many people who study chemical engineering, if they've had the opportunity to actually use process simulator like this, that is so easy, they would really understand chemical engineering. And then when they get to the plants and they prefer and you get hired and they say, oh, well, what if we change this? You know, a subsequent video, I'll show you really how to really interpret this data, how to play around with all these things and see the reality of this. But again, what have you learned today? How to log into LensaSim to build a simple system, like building a simple plant to help you to separate a benzene toluene mixture. Until we see next time, I'm so excited to join, for you guys to follow along with me as we explore LensaSim. My name remains Ibe Omodolo. I am one of the co-founders of Lensa Technology, and then this is our first product. But if you want to know a little bit about me, I am actually Ibe Omodolo. You can call me, maybe the best way you prefer to call me is maybe you can call me Dr. Ibe Omodolo. I have a PhD in chemical engineering. Just a little thing about myself. I had a BSc in chemical engineering, and then I had a master's in petroleum engineering. Now I have a PhD in petroleum engineering. I work as a development engineer. I've been working since I graduated from my PhD, working as a development engineer. But this simulator is something me and my co-founders decided to come together and make and help people who are going to be the future chemical engineers that are going to do great things. But we're trying to upskill everyone and make sure you understand what you need to know to do well as a chemical engineer. Stay blessed. I'll see you guys later. Bye for now.